When we talked about superposition and interference of waves in the past, we focused on waves that have the same frequency. But consider in this case two waves, waves A and B, meeting at a point x equals 0. They have the same amplitude, but the frequencies are slightly different. You notice here they don't exactly match the peaks. The troughs and crests do not exactly meet. Omega 2 is 1.15 omega 1 for this particular drone. So we have both waves represented here. The question, how would the wave sum look like when these two waves are going to meet up at that point? Okay, this is the way they look like, this red kind of wave. So actually, it's an interesting kind of wave because it looks like the waves are adding up in some places, adding up constructively, and adding up destructively in some other places. And this particular wave looks like it has a high frequency wave in it, as well as a low frequency feature that I'm tracing here with a pointer. Mathematically, when we add up the waves using a little trig here that I'm not going to go over, but a trig identity, cosine of A plus cosine of B, when we have the same amplitude. So it comes up easily as twice A cosine of omega LT times cosine of omega HT, where omega L is 1/2 of the difference of the omegas, and omega H is 1/2 of the sum of the omegas. Now, omega L is what we see here. However, what we call as the beat frequency is not going to be omega L. The beat frequency is going to be, it is the difference between F1 and F2, the two different frequencies. Remember the way F's are related to omega. Omega and F are related through that expression. Okay, so this is what we call the beat frequency.